AI to the rescue. Where the contractors has said that, hey, like on a VFD, on a parking garage, a project I'm working on right now downtown, it's like, no, there's no way to extract the information out of there because we want to find out what the energy savings are. VFDs have this information, virtually every one of them. So they got some metering equipment and then put it on for 2-3 weeks, got all this trending data, and it didn't make any sense because I don't think things were properly calibrated or something. So meanwhile, I did a little digging around and I found out, yeah, that VFD does have that information. And that's, I think, a better way because here's the information, here's the piece of equipment in situ, getting the data right there. So press the contractor to get that information by just pressing the buttons. So I feel a lot better about that. Now I can back up what I'm seeing measured on the VFD. I should be able to calculate what those savings are.
Yeah. Sometimes with VFDs, you might be getting outputs with VFD. But yeah, you may have to do some assumption on efficiency of the VFD to
right.
What the input power is, and then look at that input power of the baseline.
Exactly.
Yeah.
Yeah. So there's all kinds of funny things that go on, but it's not clear cut. I thought this would be, and I'm going, I'm not happy with the answer that I got. That's why I went and just dig around. It took 5 minutes to call the VFD.
happen after. We're back. We ready to roll?
Yeah.
Okay. Well, quarter of the way through, and we're gonna step into the M&V selection guide, which has had a familiar look to it over the years. It was a lot of fun. It was first launched back in 2012, presenting this out to South City Light staff. We had some excellent feedback that fed into the version 2 of that. And so just a big picture look. We'll dive into each of these 3 layers. We have an upper layer, which kind of we have cases for unit energy savers, either BPA approved, qualified as we call them, or RTF approved. Recommend you to use them. And also sometimes decide maybe a custom project's a better path, but for all the work that goes into them and the ease of incentivizing based on dollar per kilowatt hour, they're a good way to go. We also have a calculator approach, standard protocol, touch on that a little bit. But all that stuff feeds into a reporting system, which we're not getting into the nuts and bolts of that, but beats BPA Energy Efficiency reporting system. Should be hopefully seamless and easy for your utilities to get those into the system. The middle path here, really going to spend some time on, is the engineering calculation with verification. Non IPMBP adherent, and then the last one here is on the bottom is the comprehensive M&V. So take a glance at that, version 2.0 to version 3.1, and there's some slight differences we'll dive into. We'll dive into them from this far view as we approach. The top tier, though, hasn't changed either way. We still have, the unit energy saving path or a standard protocol. It's a calculator-based way, based on, we have a Northwest compressed air tool, small compressed air system that qualifies for this path. We also have some leak detection and fix repair calculators, lighting calculator. You might think all kind of fits into that standard protocol bucket.
Todd, are the calculators that fit into that bucket only BPA calculators, or will our calculators fit that bucket?
If you can report them to BPA, that would qualify as a standard protocol. I guess case by case, and I don't know how that reporting system relates to your.
Okay.
Another
reporting is custom.
Okay.
We have calculators for like cooling towers,
Oh yeah.
measures, BFT measures. We still use calculators for, but I think they reported into beats as custom.
Okay. Could be
Standardized calculator.
Yeah, and that might be something along the lines of kind of DC with V approach, custom project. I'd like to talk more about that. But yeah, when we don't have the those 2 options, we next kind of come down to this middle area, and it's kind of going from to custom into custom, even though it's the EC with V, we call this custom. And what changed from version 2 to 3.1 is this consideration of new construction. We didn't touch on that. We find more and more should have had this question come up early. Is it a new construction or major renovation? The answer is yes. There's considerable amount of content in EC with V protocol for using either a energy modeling, eQuest, new construction methodology, or a spreadsheet custom kind of calculator methodology. And if that's viewed, I should say, as a reasonable choice, then go that path. Be all considerations, level of savings, complexities of the calculations, uncertainties. But if the answer is no, then the next guidance is to go down into comprehensive, which is that end-use metering protocol. We'll definitely dig into deeper. If it's not new construction, we have this level of savings, which again, based on an impact evaluation done a year ago, we had 200,000 as a savings threshold, and we've raised it to 400,000, which is pretty high considering for a custom project. But we're confident from the evaluation that it's, we can provide the general threshold. And if the savings are considered less than 400, then ask yourself, is EC would be a reasonable choice? Other things, if it's yes, use it. If it's not, it's a new technology, don't know enough about it to simply rely on some calculations, then we would drop down and ask these other additional questions like, is it safe to measure energy? Are accurate energy measurements possible? That's kind of that question that came up a minute ago. Can we isolate that piece of equipment if the electrical wiring's too complicated or safe is the first question, but some other reasons we can't accurately measure energy, then we continue. If it continues to be yes, what are the costs of doing this measurement? How is that relevant? How does the cost of the M&V align with the savings or the incentive? You have to think about that times two. Is the duration? We don't want to meter forever. Can we meter sufficiently for a period of time? We know that we deal with rate periods, sometimes end of rate period. Can we do an EC with V approach, or do we need to measure much longer to feel confident in the savings? That's a question to ask too around duration. And we confidently, either through our own questioning of our own calculations or thinking about a QC person on staff who's going to review your calculations, we reliably predict these savings using Bernoulli equation or some other methodologies that we harken back to our undergraduate or graduate school days or certifications we get through other AEE and such. So all these questions, final decision, is EC would be a reasonable choice? If all those checks were yes, then use it. Kind of a step back option is that, EC with V applies here. But if this energy savings to this whole facility can be measured and verified by meter-based energy modeling, much simpler than spending, let's say, 40 hours developing a calculator to measure and verify savings, then consider it. It's an option on the far right, but either way, still love EC with V. You're going to see more of these projects. You think it's worth the while to put that 40 hours into it because it's going to be relevant to future custom projects using a similar approach. Put it to use. But again, we have these, if any of those questions are no, you drop down to this bottom part of EC with V, and you kind of have to ask yourself, finally, is it the appropriate best choice? The answer is yes. Put it to use. And we've never seen it, maybe you in your experience, but we've never said, no, it's not an incentivized project. We can't measure and verify it. Can't do EC with V. There's other reasons it wouldn't be an eligible project. So, but it is an option we leave there just because you've got to have some off ramp. These flow charts are endlessly lived forever.
question from online.
Yes.
How was the 400,000 kilowatt hours derived as the breakpoint?
We did a very thorough evaluation of the 200,000 threshold 12 years ago, I would say. And it was based off of kind of an internal study of hundreds of custom projects where we looked at the pre-estimated savings to the final measured and verified savings, and kind of that sweet spot, which had factored into incentives, was 200,000. So that's just a little background, the earlier threshold. So when we did an impact evaluation for BPA funded Evergreen Economics, do an impact evaluation of custom projects, they took dozens of custom projects, some of them that did EC with V for them, and others that did end use metering or some other protocol. They did a engineering calculation with verification approach to all those based on the information they had a couple of years after the fact. And they found that we could raise it from 200 to 400,000. I think they even felt we could go higher, but it seemed, based on looking at those number of projects, that a factor of two, going from 200,000 to 400,000, simple. And that, so some of the reason behind that, I don't know, hardly logical, but it's, we felt comfortable doing it. And that evaluation and kind of the supporting analysis to that is online on the BPA.gov impact evaluation website.
Todd, does the documentation that BPA has cover the rigor of M&V for under 400,000, or it's?
Yeah. It's not a, everything must be EC and bead if it's under 400,000. There's, as you see those questions, sometimes we must. And again, if it's a new technology, we certainly, it's not in this, but it's kind of relates to the reliably predict savings. So yeah, we drop down to that dark blue. You see those arrows go down, and then we can go down for under 400,000 or well above. The next layer, can be relevant under 400,000 and above. And the going from EC with V to this pre and post energy measurement is the first question: is it a strategic energy management project? That wasn't on the earlier flow chart, but as more utilities offer that to their customers, but particularly in the commercial sector, we have a CNI SEM reference guide for that. Hopefully, we'll continue to get feedback and update that in years to come. But if it's not a SEM project, then these other questions: how are the savings kind of on a buildings level or systems level? Are the savings high relative to the baseline? If we can't see the savings in the noise, or it's they're just small, and we can talk about what's small and what's high. We've metered savings 3% level confidently with some energy modeling methodologies. But if you can isolate it, either with existing metering equipment or data collection equipment, where you need to install safely sub-meter equipment, we advise going to the end-use metering methodology. If we're talking about monthly or interval meter available, the answer is yes. And if it's dependent on weather, then you can use, and the uncertainty is acceptably low compared to the expected savings, then we would continue to the far right and use meter-based energy modeling. I would also, doesn't necessarily have to be dependent on weather. We've seen some kind of mean models where just controls are non-existent, the energy consumption's flat in the baseline. Control upgrade happens and wham, we see a nice change of slope and savings. So, it is appropriate. We're pretty sure that baseline, if it were controlled properly, would be dependent on weather. So we can still use meter-based energy modeling for those cases. Done it in CNISM. We also have kind of on the far right here, a question about commissioning of an existing building. And we have a guide for that. If the answer is yes, it's pretty much a subset of meter-based energy modeling, but it's got some pretty relevant understanding of what goes into retro commissioning or existing building commissioning and recommissioning. There's a lot of different flavors to commissioning, as you well know. But that is a guide available for use as well. But if some of these answers are no, again, we come to end use metering as an hopeful option. Pause there. Kind of questions or?
Yeah, quick question. So, towards the middle of the left, are savings high relative to baseline energy? So if it's no, then you select the end use metering protocol. But if it's not very high savings, how's it going to help to meter it? Because you won't be able to see it.
Yeah, that hopefully would have been addressed in the previous EC with V. Because if you're confident, you can use calculations for that type of a situation. You would kind of stay in that realm.
Yeah.
But if for all those reasons you're not confident with EC with V and you come down here, then you would hopefully be able to isolate that measure, whether it's a VFD on the fan in the garage, or use the VFD data collection system to collect that and do your M&V. And that would be the final destination you have out of EC. Thank you. Yeah, we're always open. There's a lot of back and forth as we update these. And I always expect there's something going to jump out and bite me. So yeah, please keep any questions coming. I appreciate it. So we kind of have three different buckets of our documents. There's the protocols themselves, there's application guides, and there's reference guides. And we'll kind of the IPMVP adherent will be in our protocols, which fall under these three. Not EC with V, it's at the bottom, non-IPMVP adherent. But the method spelled out on the right hopefully makes sense. Again, looking at those flow charts, the selection guide flow chart, this equipment end-use metering, it's going to take energy measurements, data collection at the equipment level. The meter-based energy modeling, it's going to require a mathematical model of energy and weather data, asterisks, because there's other independent variables we may find necessary to account for and include. And the last one, EC with V, which is engineering calculations. It can require data collection. There can be some nameplate data collection that's very simple, but some of those projects where savings are getting higher will require some collection of pressure, flow, non-energy data to make sure or to verify your assumptions, your estimates, and to fine-tune the calculations for a completion reports. That was something that came up before the impact evaluation. It's been referenced a few times here today. When I first talked to the evaluators, engineering calculation doesn't require data collection, right? Well, not necessarily. Each engineering M&V practitioners different. But yeah, some of these projects, it's not safe to meter a medium voltage piece of equipment, not slapping meters on those. But yeah, you can collect other necessary data. You might read an amp gauge, something, using that data collection sake, it will still be collected. And as mentioned, we did integrate collecting feedback from our utility customers and M&V practitioners, program implementers. 12 is a lot of documents. Well, we couldn't consolidate too much, but we did find that end-use metering absent baseline application guide could be kind of dovetailed into the end-use metering, and was. And also energy use indexing, which was a very simple energy modeling, simple of linear regression, as one can do, energy versus some independent variable. That kind of was dovetailed to meter-based energy modeling. So kind of just to reinforce how these are related, the guides, regression reference guide, existing building commissioning, C&I, strategic energy management guide, they're all related to the meter-based energy modeling. There's certain interactions, relationships, hopefully not duplicative content, but certainly they reference each other. And I don't know if this is quite perfect, but these bottom three, estimating peak demand impact guide and sampling and the glossary of terms, they kind of all support all that stuff. It's not exactly under EC with V, but it's kind of related, useful for all these protocols. Hopefully, I don't know how many of you are doing peak demand impacts of custom projects, but kind of was we'll talk more later today, but it was kind of something we felt needed addressing a few years ago in 2018, and was sampling. I wish it were used more, but maybe it will with our new summary guides. And the glossary for M&V, we kind of had terms and definitions sprinkled throughout these, and we kind of consolidated them all into that glossary, so we kind of cut down on the fat, if you will, on some of these. So here we are. We're going to look at EC with V, and maybe in the final hour we'll walk through some examples, but we're just going to take a high-level walk through all of these. Newly updated last month, version 3.1. And again, as the previous slide showed, we're using it for savings are 400,000 kilowatt hour per year or less. It can apply if higher. It's not like an absolute don't. You'll find this guide walks you through that. There can be a case where savings, yes, are higher, but we feel confident that EC with V is appropriate. But there's limited variance in savings. We understand based on non-energy data collection, or our discussions with plant operators. It's a very predictable schedule, operations, and again, it's just not feasible to measure energy safety. It's top priority. I'll admit, 10, 20 years ago, I were installing electric meters on equipment. I shouldn't have been, and we live to tell about it. But I know the standards, NFPA, we reference the safety standard, and it's basically arc flash considerations within working around electricity. And yeah, those we don't do that anymore. So We always in meter, we are going to install a meter, we must be able to shut it down, depower, test, ensure it's not live, put on meters. You know, every utility has their own policy, and working with plant electricians, some are still pretty old school, but yeah, us energy efficiency engineers at BPA aren't doing what we used to do, thankfully, and to tell about it. In thinking about the cost too, you know, I haven't seen costs get extravagant, but we own a lot of in-house metering. And we, you know, it's in our library, and we have meter techs that we can work with to install, but you know, cost of travel factors in too. We have customers in the far corners of our territory. Travel, installation costs take into consideration too, and keeping that in mind.
Hey, Todd.
Elliot?
I'm trying to remember, if we're just using CTs for power, don't you guys have some kind of a model for predicting power factor?
Thank you.
Is that right?
Yeah, that's an excellent question. Elliot asked about, you know, we can safely deploy CTs on to capture amperage, more so than, you know, the voltage clips and getting the full kW. So when we do amperage, we often turn to Motor Master or pumping system assessment tool, which has a curve of amps measured to full load amps of a motor. And you can, using that percentage of, it's just a general curve, kind of a curved slope. At the lower end, it can be kind of unpredictable if you're at a very low percentage. You get up past 30 or 50% amp reading to full load amp of that motor, you get a pretty confident predictor, which we tested with hundreds of meter data that we had for certain horsepowers, and it confidently aligned using that power factor estimate, the nameplate voltage times the measured amps. Calculate.
Are those updated? Because I remember a long time ago, it was hard to find some of the motors.
Yeah, that's, I'm gonna make a note of that to revisit. It's kind of touched on, mentioned in this protocol, but it's not spelled out in detail. I know ESI developed a pretty comprehensive Energy Smart Industrial program on basically the testing of that data and also kind of a step-through procedure. So could be something we should make a note of updating.
And you also, I hope, specify that power factor is not an issue if you got a VFD.
Yeah, there is. Well, it's not an issue, but it is. Should be higher, very high,
Yeah.
95% plus range.
It's going to stay there.
Yes. If we're doing end use metering, yeah, on that piece of equipment, yes, it should be high. And that's something too, I'd love to talk more about, probably not in today's class, but yeah, some best practices with VFDs and making use of the data collection available on those. I feel like I talked about it years ago. We just could follow up on that. Some help, I think, all of our practitioners. And yeah, the imperfections of timing, you know, again, there are cases where working with an end use customer, we find out something was installed before we were able to baseline meter it. So sometimes ECUFE is a go-to protocol when situations like that happen. We're so confident calculating the savings is sufficient. But we weren't able to measure baseline. So yeah, there's that flow chart again. and we'll walk through some examples at the end of 11 to noon. I hope, see how it goes. Yeah, there's two main calculation approaches. One is like a custom engineering calculation, very specific to this project, spreadsheet calculations. As I heard earlier, some of you are doing kind of that for cooling towers, maybe, and chillers. I think that's where this is appropriate. You know, it's something replicable.
You got it.
Thank you. Or it could be just very custom. There's an example we added that, you know, we're not going to see a lot of hog chip fuel conveyor upgrade projects. So that's like a one-time only, but it's still appropriate. But kind of, yeah, we'd love to build a tool box of more of a spreadsheet calculation tools on a to-do list. And the other one is more whole facility energy simulation. Two examples there listed, Energy Plus, eQuest. And, you know, I have some people's mind go, oh, that's expensive. And it's not cheap by any means, but we're not going the calibration approach where you have to collect a whole year of post data, calibrate models. That's where I think the dollars really come into play, and we'll really emphasize verification of what was installed, making adjustments, but not the heavy lifting you might think of with a BP option D if you're in the rear, collecting a year's worth of energy. Not the case. And again, we'll follow through on examples later today. But the next protocol is end-use metering, for short. And call it an ECM or call it an EEM. You know, we use it when it changes load in hours. You may use this too for a constant load, constant operations. Maybe that only requires snapshot readings. But, you know, the sweet spot is in those varying loads and hours. We're just kind of unclear. We need to meter baseline and post to measure and verify. And yeah, and monitoring is feasible, whether it's in-house equipment already there for data collection or for deploying sub-meter equipment safely. And you know, it's all retrofit isolation. You know, we're not too concerned. Maybe there's some, you know, heating load reduction from some, you know, interaction, but it's limited, and things like that we can either deem as insignificant, negligible. So retrofit isolation, and it does require energy measurements before and after. I think we should still be able to call it end-use metering if it is amperage and going through proper procedures, voltage, and estimating power factor. I would still characterize that as end-use metering. And again, it relates to IPMVP, option A or B. Option A, we don't measure every independent variable. Maybe a snapshot on the constant load is sufficient. We measure the operating hours longer with a data logger. So there's different flavors. Option B, though, is the measure everything approach. And just again, re-emphasizing that flow chart. This isn't intended for new construction. Asterisks, though. We, as we added that absent baseline into this protocol, it does incorporate kind of that end-use metering opportunity to, you know, in cases where it's new construction, major renovation, or raw replace on burnout, where we couldn't measure baseline, we can measure post reporting period, and with that data, we can do some analysis to calculate what the baseline equipment whether it's code, standard practice, is it, and then determine the energy savings from that. And yeah, if there's some complexities with a lot of interactions or energy flows, we kind of think stepping back more to the whole building, maybe the whole system level, like a compressed air system with multiple air compressors and dryers, and other pieces of equipment. That's still more whole system, kind of an option C approach. You can certainly spend a lot of money and employ sub-meters and get down there. But yeah, that question, the cost might be more, how can you do that for whole system approach? There's a lot of equations in this because we look at a lot of different flavors of constant load, constant schedule, time schedule, I should say, constant load, varying schedule, varying load, constant schedule, or varying load, varying schedule. All that's summarized in that blue equation there. So summation of load times hours can be very simple. It's constant load, constant schedule, or it can get more complicated if you have more variable load, variable schedules. And there's some examples here, kind of using bin analysis. You can break them down into a very short list of maybe 4 bins. May take more than that, depending on the complexity of the variance of the loads and hours. So hopefully our examples provide you with some good guidance there. I think one of our examples provided a little later today should. So the impact of the equipment, we may have the baseline equipment operating one way, but it could be a controls project that changes the hours of use per load, and whether we want to pursue option A or B. It's all spelled out in this protocol. And again, demonstrating baseline and post case, documenting transparently loads, the hours of use. And again, giving you flexibility on budgeting for this and other resource constraints. You really could choose option A confidently when you understand the certainty of the parameters and you measure those, and you are confident the others are reliably estimated. And this can require using nameplate data on the equipment, cut sheets. There's a lot of AHRI cut sheets lately, and some manufacturing performance curves, pump curves, air compressor performance curves, confidently and measure the most uncertain parameters. But yeah, the option B, more expensive, more rigorous measuring energy, flow, operations, understand complexities, and kind of that variable load, variable schedules, kind of the most often scenario for using that. So practical applications using that key parameter data collection for existing or new metering. And we want to, again, we report savings on an annual basis, but we don't expect measuring energy for a year. Again, we have that like at a sawmill or some industrial facilities where it's kind of commonly, I'm not saying this is thou shall, but commonly like 2 weeks of metering on new equipment's done. It's It's not driven by weather. It's not driven by, let's say, annual production. But if we capture typical production or typical operations in 2 weeks, we can, it's all good data. We can confidently extrapolate that to an annual basis. Some could argue maybe a week is sufficient too. And it could be if that week doesn't have an anomaly. It's kind of why we go out to 2 weeks, because it might be an anomaly one of those weeks. So, extrapolating, got to consider holidays and some other shutdowns that may not have captured in Europe. So taking that into factoring, using end-use metering and any approach really to extrapolate to a full year of savings. But all that said, a lot of terminology. The M&V plan and the report may have a custom project proposal form. You and your end-use customer. You may have a completion report for your end-use customer or for your internal purposes. But to follow, aligning with end-use metering, here's some of the things that the loads should define. Detailing any proxies. If we are taking maybe some short-term sub-metering of power to fan speed, collect that and then create a curve from that. Detailing that, being clear about it, and just putting, if you are going to bin, kind of like this example shows, we have power overflow, CFM, and it's kind of nicely shows the curve relationship of a range going from, let's see, roughly 12,000 to 36,000 CFM. So that graphic on the top nicely shows that relationship. Down below, the bottom one has this kind of a bin analysis methodology that goes frequency of 2,000. 12,000, 36,000, you see how the count, data collection, so the bulk of these are in the 28,000 to 36,000 range. See a nice distribution of data collected there, which would be useful for providing in a completion report. And each these protocols generally has a similar reporting period or reporting requirements spelled out in them. But there's some unique ones to each, like for end-use metering, specifying whether you're using kind of a estimating option A approach, or you're using option B where you're metering pretty much everything to be described, as well as these other bullets. And these kind of are more aligned for in our custom project option 1 template, kind of we just have blank, fill in the blanks for kind of each of these, for many of these. So in the completion report, these as well, just for reporting purposes, for future analysis, these bullet points are helpful too, for future evaluations. Providing all that too. And we can also have situations, even at the end-use metering, where a non-routine event and adjustment occurs. But it's not as complicated, I wouldn't say, as a full build meter-based energy modeling approach. But if they do happen, clearly describing what happened in the adjustments. So folding in to the end-use metering was the absent baseline. And it's again where you can't measure the baseline. Either equipment was installed and we weren't aware of it. Some equipment burned out. We have to consider code baseline or standard practice baseline, major innovation, new construction. So this protocol, this approach fold it into the end use metering protocol or for situations. And yeah, we may have electrification example at the end of this to talk about. Either the end at before noon or maybe more at the 1 to 2 time. Gonna go for a couple more minutes and we'll take another break. You know, this, we're pretty excited in 2012. Strategic Energy Management was launching and whole building energy modeling, interval data was becoming more available. And, you know, we had an option C excitement, you know, but turning to just option C in the IPMVP, good content, but, you know, just a lot of practical things we just couldn't quite find in there. So piecing that, like the ASHRAE Guide 14 and some other guides out there, you know, we developed this, and again, that's the first bullet. What do we mean by high level of savings? Used to be, you may have heard the old 10% rule. It's commonly when we had just monthly data, and I think even IPMVP, one of their earlier core concepts, had that. I don't think it's mentioned in there anymore. We've measured verified savings down to the 3 to 5% level for SEM, and for some whole building, commercial buildings. But at its simplest, yes, you have a high level of savings relevant to baseline, and this is a good option to turn to. Particularly if you have a lot of measures being implemented that have interactions, you know, lighting upgrades, which we have a UVS measure for, impact, heating and cooling of a building. You have that on top of building controls being installed or HVAC equipment being installed all at once. This is a good protocol to turn to. And yeah, we have whole building energy data. If we don't, well, we've got an example what we can do then. If we have either utility kilowatt hour data, or some industrial facilities, they have their own process facility energy data meters that we can confidently use too. And that could be down to the hourly, rolled up to a daily or even a weekly level. And predictables have a subjective term, but we can model confidently using whatever independent variable we explore and agree on as a driver of energy. Could be a schedule, could be weather related, could again be industrial plant productivity related. And we seek low model uncertainty. May not always find that. That's a whole other training we're kind of looking at exploring. We may roll out some more meter-based energy modeling specific training 2025. Let me know if you're interested or not. We'll like to, yeah, do some more of that, because currently we're using quite a bit of ECAM still, energy charting and metric software, Excel file add-on for commercial project work. And had some workarounds with that because of IT Excel add-on issues. It's still doable, but yeah, we'd like to maybe talk more about that one to two as well. With that, I think we're at the hour. Take another 5-minute break. And, come back.
I got to change computers. I forgot my PowerPoint.
Oh.
So We'll see what happens. It's a surface, and so it needs a USB-C.
Oh,
You do?
Yeah.
Oh.
Wow.
For the rescue.
Oh my gosh, thank you.
Harry would be,
They're like
Yeah.
it must be
three other people.
Yeah.
For some reason,
Show
when they stopped
Webley.
Yeah.
Yeah.
offering them to
There is
people,
some
I had one of those special.
All in.
Like that.
Somebody got it, maybe 80% down.
That's how I do it.
This presentation will be posted.
Yeah.
On whose website?
My personal one.
So many websites.
Yeah.
There are.
There'll be a presentation will be there.
Because they have to centralize, well,
Yeah.
is all this stuff you're showing available on some central webpage you guys have?
It will be.
Well, great. That's helpful.
These PowerPoint slides, yes.
No, but it looked like at the beginning, you had it looked like a screenshot where there were like jumps to.
Yeah, those are all.
Is that a central, because I don't know where that is. Can somebody send that out to us?
Yeah, we can. The web's link at, the address was up there on one of these other slides, but we'll, get back to it before we're done.
The link?
Yeah.
Okay.
Yeah, there's a lot of good things to discuss. It's, there's certainly more details we can talk through 1 to 2 on this, and I'm really appreciative of that. You want to take some good notes for future discussions we can have on these technical topics. Kind of trying to get through this. We have continuing on meter-based energy modeling. This graphic here shows looks a fairly flat heating slope going from about 0 to 52.2 degrees. And then at that change point, see a drastic slope increase due to cooling load as temperature goes up from that. So there's some neat tools. ECAM can help you, identify that most best change point based on the data collected, which is all those dots in kind of purple, and best fitting the curves, I should say, the heating and cooling curve there and the intercept shown there. To do that, there are some kind of more Excel handy approaches to finding that change point, but you'll find that ECAM or some other software analysis tools can do that. I think there's a NMECR software that's R-based. Also kind of gives you some good change point model approaches here. So that top part shows the energy over outdoor air temperature. Kind of what we see down below in the 0 line is the residuals, which are the differences in all those data points to that curves shown. So we see kind of the bigger cloud of residuals there in the 60, 80 degree temperature range. We would look at our overall statistical characteristics of this model, the R squared, coefficient of variation. Drawing a blank. There are some other ones that are very well defined in this and the other documents. And we have, this looks pretty detailed. I imagine it's an hourly or daily model shown there over a full year. And we would note too, this method's somewhat sensitive. It is not somewhat, it is sensitive to non-routine events. And we had a number of those during the COVID years, the custom projects, 2020, 2021. Feel like 2022, we're back to normal. But for some of those projects, pool related or commercial building, we actually had to harken back to in some cases, a 2019 baseline, find that typical operations. But more and more, we're newer projects finding 2022 and 2023 data to be representative of typical operations of these buildings. There's the equation, and we will, one of the examples in the handout I'll share later, does have that normalized energy savings approach. But this formula looks very familiar to what we saw earlier in the M&V slide. And what we have, again, that apples to apples comparison of our baseline to our reporting period, routinely adjusting that baseline energy, subtracting the reporting period energy, and again, that non-biased plus or minus non-routine adjustments to the reporting period conditions. So maybe, again, equipment added, some control changes took place, non-project related, we must account for, whether it increases or decreases the avoided energy consumption.
Right, more examples what routinely adjusted things would be, like what kind of variables we're talking about there.
Yeah, mostly commercial building based. I've seen or temperature. Depending on the equipment, it could be more of a wet bulb temperature relevant.
So how does that compare to like normalizing for weather? Like what's the difference?
Well, okay, in this situation, we're really just routinely, we've developed a baseline energy model. Like the 12 months, let's just say, of baseline data. And we have found that relationship to outdoor air temperature. Let's just say that's our only independent variable. And we've got some good statistics on it. And so that model, we can collect reporting period temperature, whether it's 1 year or several months, let's just say, a sufficient time period, a reporting period temperature, and we can drive that baseline energy use, adjust it, let's say, to the reporting period.
Okay, so normalizing, you'd be talking about adjusting the model versus routinely adjustment is adjusting the outputs.
Yeah,
The measurements.
yeah. The normalized term normalized kind of has multiple meanings in a way. We mainly talk about normalized. I use it in a term of normalizing to typical typical weather, 30-year weather data for that location. I would take the baseline energy model and I would adjust it based on that normal weather data. But I would also need to consider the reporting period energy and develop a model of it to that weather, and then normalize it to that same 30-year weather data for that apple to apple normal conditions.
Do you guys specify what good statistics are for any specific model?
Yeah, there's a list of them in the regression guide. It's not in the meter-based energy modeling. It references the regression guide, and we clearly have them in the C&I reference guide. So, yeah, don't quote me on it off the top of my head, please. But they are listed, and they are, there's some different values, like coefficient of variation, depending on what level of data frequency you have, whether it's daily, weekly, monthly. R squared's kind of just listed there. It's not, none of these are stand by themselves. You kind of have to consider all those R squared, C sub B, and
Critical T.
normal.
Critical T.
Yeah, CT stats for your independent variables, all those, and your normal mean biased error to overall model. We can maybe flash those up at the end of this, or get that 1 to 2 hour. But they're there. And again, reduce the number of guides. We folded in the energy use indexing, that very simple energy, most simple linear. And again, we use the term normalized there because that will sometimes be applicable when you want to extrapolate out to a full year. Like use some typical normalized production values that you did capture during your M&V period to annualize savings. This slide here is probably mostly relevant to strategic energy management, but it's relevant to really any management of energy that utility might be with a facility that's multi-year engagement. We at Bonneville report incremental savings into our system, so it's can be, in some cases, where backsliding or negative savings occur relative to the previous year. Those savings go into our system. And, I remember back in 2010 when I was in Washington DC to talk about superior energy performance, this whole building energy modeling, one of the consultants said, "You're opening up a can of worms with this whole building energy modeling," because you do have some cases where backsliding occurs, non-routine events happen. How do we adjust for those? All that stuff. But just when do you re-baseline? You're engaged with your customer for multiple years. There's no silver bullet answer, but we rolled out energy management for like a 5-year agreement. And we went down to we actually went to 3-year, but we went also to a 2-year agreement where we are today. And if you're engaged with your customer for 2 years, you re-enroll for another 2 years, you might consider facility still kind of operating the same way. We use that model from 2 years ago, or do we need to re-baseline? There's some content in the CNI SEM guide that gives some guidance there, but no silver bullet answer. This one, I would sure love to hear of a utility tell me they've used this guide. It's kind of sad, but things I love, but I want to hear. But yeah, it's been living on for 12 years, and it's an application of meter-based energy modeling, but it's instead of it tries really to align itself with commissioning projects. There's some terminology related to commissioning, how our M&V aligns with it. So this is for kind of like that whole system, option B, or whole facility, option C. And some of the examples you'll find in here is not for that full year. It's very short term, weeks or months, baseline, weeks or months of post to measure and verify savings. I think some of the commissioning or control projects, HVAC control projects, you can find relevant here too. And I know in-house, really trying to get more uptake of commissioning projects in the commercial sector. So maybe there's some more discussions we can have here on whether this can be used more, or if there's maybe some opportunities to look at some other M&V methods. Again, family of meter-based energy modeling also includes that regression guide, which has some of those statistical references Elliot asked about, as does the CNI SEM M&V reference guide. Oh yeah, where did that find? So we're going to walk through a couple examples, and these are, find them, you get them in your own hands. They're in the M&V selection guide, but again, I'm hopeful you may have some, well, I may have done it this way, or I may have done it that way, comments and feedback. But here's some recent projects that were evaluated, and we thought they'd be good to genericize, remove names and content. And it's more kind of verbal description walkthrough. There's more detailed examples we'll do before we're done by noon today. Maybe we'll get to those before our next break too. But it's a hospital, happened to be in the southern Oregon coast, and it has an air-cooled chiller that serves air handling units operating around the clock, and the chiller failed. And, it's an emergency care center, so a temporary one was put in place, but, the temporary one couldn't qualify as baseline. May have been diesel fired far as I know, but it, so we had to say, well, since it's a burnout failed chiller, the new one must meet whatever local code requirements are. And apparently, this Oregon served location, that would be ASHRAE 90.1 2022, and that full load efficiency is rated at 8.2 kilowatts a ton. And they want to put in something more efficient than that. So, the new code, the new chiller that was selected has a full load efficiency of about 0.9 kilowatts per ton. So definitely a 25% improvement if we're doing the math right. But, the equipment, baseline equipment, and it failed. Couldn't even accurately estimate it based on system loads were unknown and couldn't be measured. Suppose we could have done something with that diesel temporary fired chiller, but apparently that wasn't felt representative. So I ask you, based on our couple hours of training today, what protocol seems most appropriate? Okay, don't have to answer. How about EC with V?
Yeah.
V? Well, based on some engineering calcs, they were expected to be far less than 400,000. It wasn't selected because the baseline chiller loads an hour of operation couldn't be reliably estimated. Now, if that was the case, say, yeah, go with EC with V. But for whatever reason, that couldn't be the case. Well, how about whole building energy model? Oh, I see some head shakes. Yeah, the expected savings were small, well under 2% compared to baseline consumption. Sorry, floating action. How about verification by equipment or end-use metering protocols absent baseline measurement approach?
Yeah.
I see some yeses. Yes, this was chosen because, again, small energy savings. We harken back the flow chart. They're small, and they, it was failed equipment. So we couldn't rely on EC with V, so we did think this approach most applicable. And, we do have some spreadsheet calculations required. That's some similarities, EC with V. We do have to, again, do some analysis of what reporting period data we collect to reflect on what the baseline energy consumption would have been for that code compliant chiller.
Don't you need part load efficiencies?
Yeah, this equation, we've just talked about full load. So yeah, we would collect some post data and capture hopefully a range of full and part load.
It should be on the actual specs.
Yeah. We do have it 25, 50, 75, 100%. Yes. And that's what we'd rely on for the code compliant chiller. You can collect, and yeah, well, this is a wow. So yeah, depending on post data collected, which could be trend data from an in-house data collection system, or installing post metering, and that's kind of what this way too wordy slide describes, and you can read it in the selection guide example. But yeah, we're not going to record forever, not going to record for a year, but we can look at some on-off trending of pumps and chilled water flow from a test and balance report if available, collecting data for 6 weeks, covering again that wide range of operating conditions, spot measurement, the chiller power at the motor control center. And, you know, this might be considered overkill when you read that the final savings are only 20,800. I wouldn't disagree, but it does kind of walk you through kind of going through the approach versus just assuming some loads. So a little heavy, but it's an example of absent baseline using end use metering. And we'll leave it at that. But I will say here that equipment manufacturing performance data was used to estimate code baseline chiller consumption. Questions, comments?
How were the operating hours post-install confirmed?
Well, over 6 weeks of data collection, based on load, collected that could capture load of the water, chilled water, and that could be argued if it's highly dependent on outdoor air temperature. This piece of equipment was for an emergency care, and I would assume conservative approach would be, if we're capturing this data 6 weeks in the heat of summer, coastal climate of Oregon is probably not going to be crazy hot, right? You have to take that factor in as you extrapolate out. Yeah, wouldn't want to make a research project out of it. Just collect enough data, sufficient data, whether it's a few weeks, 6 weeks, it's quite a bit. But if time allows for it, there's engineering uncertainty. Your QC engineers request that, kind of finding that happy medium, still confidently estimate annual savings for this project, kind of using code compliant chiller, which I'm sure there's multiple choices, but finding one that's has the data for part loads too. Step through that. Here's the one that might be even more interesting. Why both these examples happen to be on the Oregon coast. We need some in the Puget Sound area, future upgrades. But we have a school that has out there on the coast. They have a heating needs. It has a diesel-powered steam boiler serving steam heating coils and air handling units and unit heaters, and serving a 50-gallon domestic hot water system too. So, this facility, I don't know if they were decarbonization driven, but for various reasons, they had to step away from this diesel boiler and wanted to electrify. And at this time, which was a few years back, there was a code compliant resistance heating system for that locale, or they could go better on the efficiency side and install heat pumps. And the proposed heat pumps with electric resistance heat strips and package unit included demonstration demand control ventilation controls. So 120-gallon electric heat pump water heating was proposed to replace that old 50-gallon unit. So hot water capacity event for the gym's occupancy. Further background, we had records of the diesel consumption, monthly amounts for the last 2 years. Again, that old boiler system was antiquated and required replacement, end of life, electrification. But we needed to consider that code compliant baseline. So just for background, early energy engineering estimates. Savings were estimated for that code compliant electric equipment to higher efficiency heat pump water heating. So it's pretty low, 104,000. You know, had the fund taking natural gas or diesel and doing some kind of estimating of boiler efficiency, figure out what is that heating load of the system, doing the conversion of MMBTU to kilowatt hours. That's kind of what's at play in the background here. Get to that estimate. And the average efficiency improvement is based on this heating season performance factor. And initial savings were estimated as the difference between that baseline and the new heat pump and package unit. So although this project changed the fuel, savings weren't impacted by the fuel change or eligible for incentives for the electric, hypothetical electric to the higher efficiency electric. So that's that last bullet emphasizing. Okay, all that said, what protocol seems most appropriate? That's okay. Step through it again. EC with V. Perhaps. Savings were estimated at less than 400,000. And that M&V selection guide offers, as you step through it, either the engineering calculations with verification, but remember, there's that kind of far right optional one, which is meter-based energy modeling protocol as a viable method. And because we had post data from a dedicated, well, we have pre and post dedicated energy, electrical energy from the meters available. And we also have, the meter data from the diesel boiler consumption. There's a lot of what ifs, I know, with that, and the assumptions in converting that to an electrical code baseline. But I just want to emphasize there's flexibility in selecting a protocol, and that verification by meter-based energy modeling was selected. And I think you'll find, hopefully, after it was completed, and it's a good, I think, M&V practice, instead of waiting a full year and then collecting data and doing analysis, initial 3 months of data was collected just to do some preliminary checks for the savings apparent. And due to time allowing, we could say 6, 9, or 12 months was how much data we wanted to collect. But in this example, 12 months post data was collected. And using that EPM software, whole building analysis compared to baseline energy use and post installation. And this would be our normalized savings approach. Robert?
Why didn't that qualify for the existing baseline, because the existing equipment is still working?
Well, yeah, because they're converting from diesel fuel to electricity, that's why we couldn't use existing equipment. And I'm going to make a note of that. Yeah, there might be a flow chart opportunity that emphasize that in our selection guide. So yeah, because of that fuel change, we had to look at that hypothetical code baseline. And what was nice, a benefit of the question.
Yeah, well, for something like this, do you make a customer wait a year before you provide any incentives, or do you provide like progress payment for installation for partial savings or something?
The EPA will incentivize the utility at the completion report 12-month stage.
Okay.
So, yeah. There have been some utilities that might choose to offer incentives earlier, but that's kind of a risk. It's what savings information is verified. So we will incentivize. There are some I'll say that to 1 to 2, but make it amendment. There's further discussion we can have on that topic. Yeah. There are some emerging tech projects, I may have mentioned this earlier, that we will kind of apply an EC with V M&V plan to kind of provide an incentive earlier. We want a meter long extended before that. So that's for more research purposes.
We have a question from online.
Please.
How different were the final kilowatt hour savings determined by metering from original estimates? Estimated savings incentives can have a large impact on decision for above code efficiency solutions, especially in rate-based scenarios, as can expected incentive payment date compared to in states.
Okay, I will address that. That was kind of the thought. You know, the initial estimate, engineering back here was 104,000 kilowatt hours, and BPA will estimate an incentive based on, let's just say, 20 cents a kilowatt hour back in this day. So be about 20. Do the math, Todd. About 20,000. Yeah, somewhere in there. $20,000 range. So, you know, it's capped at typically 70% of project cost. So if the cost being far exceeding, you know, the incentive is going to be driven by the savings times the incentive rate. So yes, this M&V savings were higher than estimated. So BPA's willingness to pay is higher now based on 20 cents times this, which is almost $30,000. Let's just say roughly. So yeah, that willingness to pay by BPA, now there is that risk factor. If savings were less, obviously would pay less. I know some utilities will cap; they won't pay any higher than whatever the rate is times the estimated savings, even though you might get more incentive from BPA. So yeah, we want to do our best. There's a whole kind of, I think there's some good content in EC with V for best practices for calculating savings. It's relevant for that earlier estimate. But yeah, we'll be following the protocol like meter-based energy modeling. We're going to take the final savings based on what was measured and verified by the incentive.
Is the 70% cap based on hypothetical marginal cost?
Yeah. Yes.
So you have to do all that research?
Yeah. Yeah, that's one reason we developed that cost documentation guide, was to be better at laying that out. For these hypothetical electric baselines, you have to call it RS needs or some methodology to estimate, because vendors aren't going to typically, I've called and never gotten calls back. Give me a quote or emails that fall, dead, never responded to. So yeah, either you have a similar project where you have that code compliant baseline cost, assume the installation costs are approximately the same, and so you're just looking at the difference between code baseline equipment cost to your higher efficiency equipment cost. That delta times 70% is that cost. Yeah, that's it. Did I describe that? Okay. So, but yeah, RS means previous costs. I think there's an opportunity there to close some tables. We could all point to an update every couple of years, depending on how costs might change over a time period. I answered that question or satisfaction.
I hope so. Greg, if you had additional needs,
Yeah.
chat.
Please, because yeah, this is coming up with industrial heat pumps too. And when is the electric resistance boiler acceptable as a hypothetical baseline? And when do we have to look at a lower efficiency industrial heat pump to the higher efficiency industrial heat pump? There's some supplemental slides we may have time for we're done here today. Okay. So I get this, take another break, 11. We pointed to that BPA M&V protocol slide or website. There's other things there than just these protocols and guides talking through today. And yeah, there's always potential updates, a commercial custom project, impact evaluations underway. I think that includes option 1 and option 2 utility. So we'll see what comes out of that. And again, we're always welcoming feedback from everyone here in this call and this today, and consider future updates to those. So yeah, these 40 plus signs, you hit those and see some future things, some current updates. And one of those were these summary guides, which was second from the top. Again, we got feedback from utilities and program implementers. I wanted the Cliff Notes pocket guide for the main ones used for M&V, maybe for some other ones that are less used, but could use a little better short summary to motivate folks to use them. So that similar approach for each of those spelled out there, and the 5 guides for EC with B, end-use metering, meter-based energy modeling, sampling, and peak demand impacts. So again, just kind of showing those relationships of our protocols to guides. And these were the 5 come out of that. There they are, snappy looking. Very pleased with the graphic design work of the Facility Energy Solutions and their team. But yeah, 2 to 4 pages each, very concise. There's links within those. I mean, they're available electronically. I'd love to see, and maybe through our marketing, we can kind of, we call them, develop nice hard copies with clear, sleek, something you can carry with you out in the field if you so desire. But there's the page 1 of the engineering calcs with verification protocol. Overview of calculations, when to use, when not to use. Hopefully all those bullets bring familiar to what we've talked about today. And page 2, these little columns on the procedures, steps for custom project, steps along the way, preliminary data collection and post installation and collection. The summaries of the reporting requirements, tips, and again down here in tools and resources, there's some links to some weather data, software, and guidelines or energy codes. You know, we couldn't have everything, just kind of at the state level. You know, your Seattle City has your own codes as well. The AHRE website, which I've been using a lot lately. Page 3 kind of shows those 2 different approaches, EEC with V, side by side. spreadsheet calculation, you know, relative to a simulation model. Should, before we're done today, walk through examples of both of those, but nice layout of taking those full chapters and subsections and consolidating them down into nice little bullets. I think the last page, I believe this is the last page. You know, we also wanted to point folks to the examples that are built in. It's not every example, there are more, but some of the most helpful examples for a M&V practitioner. Compressed air and dryer with increased capacity. Example 1, new windows, an HVAC system and a stool, high-speed roll-up door, more efficient configuration of conveyor systems. Page numbers included. And sorry, the links to those BPA resource library, direct link to the protocol, and a direct link to the selection guide. Similar, I'm gonna go through all this, but yeah, here's first and second page for end-use metering. Last 2 pages, where again, you know, these 2 pathways, there's the end-use metering of existing equipment and the new equipment, and to the right in blue, it's kind of that absent baseline approach where we couldn't measure baseline and the use methodologies to best estimate that with collected reporting period data. A lot of examples in this one, and I think any of these were updated this time around. They were pretty good examples. Yeah, really felt the need to update the examples in EC would be. Similar with meter-based energy modeling protocol. Again, if interested, reach out and let me know. We are planning to develop some specific training for this in early 2025. Kind of mostly ECAM related, but it's not ECAM centric. It's kind of more overarching with some use of ECAM if you're interested. But there's some other M&V tools and resources listed there. I got a little carried away, maybe. Altrack, Universal Translator, and NMECR. Statistical analysis. Before I retire, I would love to dive deeper into R. Anybody here use R software analysis? If you'd like to, reach out. Maybe we can team up, learn side by side. But yeah, there's a lot of resources touched on ASHRAE Guideline 14. Kind of mostly relevant is fractional savings and certainty, which we do calculate as one of those, as we call them, a statistical characteristic of our energy models. And yeah, a little clarity around when an energy index could apply a simpler straight line 2-point regression model versus a more complex multi-point energy model. So there's those 2 applications shown side by side and examples provided on the last page there too. And yeah, the same for peak demand impacts, sampling. Anybody in the room or online use this for estimating demand savings from an energy efficiency project? No. No. I did. Well, maybe in the future for you. We currently don't incentivize, demand, or we've had, EPA's had demand response offerings over the years, but it's kind of more for the end user and utility use. If they really want to dive into seeing how custom project, energy efficiency project, estimating peak demand impacts, this is a tool rolled out. We did NESI did a capacity analysis study at a few industrial sites, SEM and custom project, more of a learning experience, and we presented it out at AC Triple E. So, anyway, the tools are there, and the sampling, again, the guide itself, when you have a case where you can't use whole building meter-based energy modeling, but you have hundreds, let's just say numerous equipment upgrades. Not cost effective to meter everything, put sub-metering, but you can deploy some sampling strategies as described here. Oftentimes, well, three, let's just choose three. 3 out of 100. Let's kind of revisit this. Maybe that's okay. Let's step through the process as this will walk you through it to choose that right sample of equipment for baseline and for reporting period, without metering everything, without just guesstimating an approximate number. Sometimes engineering judgment, can reasonably get you there, but this sampling strategy is useful. Yes, it's got me choked up. Excuse me. Couple examples there. Hopefully, yeah, these summary guides will maybe help get them more used in the years ahead. I wanted to go to the top of the hour, but I may ask to take a break, and we'll come back at 11 and walk through more examples that I have in another sheet or another document. Thank you.
Yeah.
Sorry, I have to record that. Ready? I guess we're fast. Thank you.
I talked to you, you said you had some questions.
Hi, here we are,
Comments or areas for clarification?
1 hour to go. We will have lunch, then the 1 to 2 o'clock hour. Maybe talking through some thornier issues you found worth discussing later, or just some other topics that arise. Really appreciate the feedback and yeah, the questions that came up so far, and keep them coming. We're transitioning. We'll return to the PowerPoint if time allows. I would like to, because there's a couple slides I think relevant to some of our earlier discussions. I kind of wanted to walk through more examples, and primarily new ones from engineering calculation but verification. And this supplementals will be provided to you as well, because you know I know you want to take some of these, take printouts, make posters of them. So this document will allow you to do that at your leisure. You know, this page just succinctly tries to look again at the early replacement and replace burnout or new construction, major renovation, and the guidance for selecting the appropriate baseline. So we're not going to walk through all that. It also is that full page blowout of our M&V selection flow chart. If you're like me, I have it printed out and on the wall of my office. So
Not at home too.
no, not at not yet. We did update it, so maybe I should. But yeah, one example, and I've tried, hopefully I've removed all the glitches, because trying to copy it from the EC with V protocol, this Word document, led to a few unattractive things, but there's a lot of words, but what we're going to go through kind of 3 examples. One, EC with V using a publicly available software tool, which is the Northwest Compressed Air Regional Air Tool. There's an acronym for that. And why it wasn't used for just as a standard calculator itself. Well, there's some differences between how that calculator is best suited for a one compressed air system. What we had at this facility were 3 different smaller compressors that were replaced by one high efficiency air compressor, along with some other compressed air system upgrade that the calculator can't handle. So we had 3 existing compressors in place as a baseline. They want to put in a 100 horsepower VFD compressor, higher efficiency, but also could meet some future capacity needs that the 3 existing compressors couldn't meet. And so along with air compressor upgrades, we have a cooling fan VFD, cycling refrigerated dryer, and a mist eliminator air filter, less pressure than your standard off-the-shelf air filter, and a zero loss drain. A lot of things packed into one project, but this calculator can handle that, but we need to, in a custom project, be clearly differentiate how these savings are achieved or calculated, since this is EC with V, for all of those measures. Compressed air systems have been done a lot of custom projects over the years, and that's why we developed this tool. The tool doesn't, there are, if you read the old IM, used to be it's only appropriate for 75 horse and under compressed air systems. We bumped that up to 150 horsepower recently. So if you weren't aware of that, it is useful for higher horsepower systems now. And we expanded it too to these other measures. So this tool, again, you can find it on our website. And so it's going to be used for an EC with V approach, not necessarily measuring energy before and after. Okay. But we're not just looking at that air compressor alone because of the other system improvements described in here. So describing the baseline conditions, we have these 3 existing air compressors, different types. One's reciprocating, 2 are screw. That, knowing that you have a power to capacity curve, best estimate power based on rated flow, which, this flow conditions may have been kind of off of nameplate, rated flow at power, peak power. For these 3 are listed here, and summing them all up, they can meet the system facility capacity needs up to 469 CFM. And again, that's kind of based off nameplate. So using that compressed air tool, you can plug these in, and knowing kind of what some general flows are, or estimating, calculate what that baseline estimate is. But not a spoiler alert, we do want to kind of adjust that baseline based on what reporting period conditions we find. We'll explore that a little bit. And the non-VFD cooling fans were estimated based on nameplate, so they're added too, not ignored, even though they're small horsepower. Sorry, this is not the most like the way I developed the other example in the PowerPoint, but yeah, for those full load of the baseline, we have this is power use, 175, 50, and 25% load. And the air dryer, which is non-cycling, rated at 500 SCFM, which is beyond what the system can deliver, but it was estimated in 3, based off of some nameplate information. And they probably have one of those timed water removal valves in the system, and there's some estimation on how much air is lost in that a little later down in our calculations too. So again, the new system's higher efficiency, it better be, it's got a VFD matching load to demand. It's got higher capacity, shown as 508 CFM to the earlier 469 of the baseline. It has an apples to apples PSI rated flow, and it has a large receiver. Receivers, tanks are useful measures too, so the air compressor doesn't have to run this full all the time when you fill that tank. So, a lot of new VFD air compressors can have some data collection built-in capabilities. This one did, so that monitoring airflows for 2 weeks and summarizing that in the table below show how demand load profile is. And we love pictures as part of EC with V2. You may not specifically require that in your completion reports, but we don't require them either, but I think it's a nice supplemental documentation taken from afar. But there is the new air compressor in place, and the table above kind of characterizes bin analysis we talked about earlier, kind of that, these ranges of percentage of maximum airflow and that average compressed air at those values and the percentage of time from that data collection should all add up to 100 that we could extrapolate out. But the new dryer and the mist eliminator, low pressure drop filter, and were just modeled as a 4% reduction in operating pressure, and the zero loss drain savings were modeled as a 1 standard cubic foot per minute reduction in demand side airflow, compared to the baseline. So again, all these assumptions could be argued back and forth. Maybe that's not the right level, but it seems pretty conservative and documented and applied in this analysis.
And Aaron online said that Sea Light typically does 10 minutes. That standard 10 minutes.
10%.
Okay, for compressed air projects, that's well and good. I mean, that's above and beyond these 5. So that's, thank you. Sure, that's
Done over the years. So.
yeah, no argument there. I will note that using this tool was part of our impact evaluation too, and the evaluators used a tool called AirMaster Plus, available through the Department of Energy's Measure Suite tools. And we used to rely on that more, and it's a great tool for some very thorough, detailed analysis of compressed air systems. But the results were very comparable for smaller systems like this that used it. So we felt comfortable. 5 bins in this case, but you could use, I'm sure you could find ways to make 10 bins, use this tool as well, if you desire. But what's shown here for the air compressor alone at the 5 bins, kind of breaking out those loads from the data reporting period data collection shows an annual consumption. So those percentage of the times are annualized here. It's funny walking through this. The new dryer did spot reading of it was taking. It's not absolutely necessary for EC with V, but does show a difference between the baseline dryer delta of 1.7 kilowatt demand savings, and assumption made that dryer runs at least as many hours as the compressor. So I think the earlier estimate may have used 8760 based off of the recording period data collection. That was dropped down to 6,474 hours a year. And you can see the energy savings for that dryer alone. So again, summarizing EC with V, all these measures, quantifying for them. We have a final here that I think, sorry to say, I didn't change it because I need a note to myself. I think this accidentally mistransposed the post-energy consumption. This should be a less than that, I found as I was preparing this class. But I didn't change it because the methodology is just good enough for us to walk through it. I have to revise our guides when I get back to the office. But yeah, clearly identifying the 3 measures: air compressor, cooling fan, refrigerated dryer, savings for each measure, final savings summarized on the bottom right. And so, transparency, data collection approach. We're not measuring energy before and after, but we did collect kind of percent capacity, operating hours, relied on, we may have had post kW from the VFD on the air compressor itself. But, we had to estimate kW for those 3 air compressors. Since we were using EC with V, we didn't have to measure energy. Now this next one, there aren't any questions about that. It's funny, this is an old example in EC with V. It uses kind of a whole building simulation using eQuest software. And the measures are window upgrades and HVAC replacement of heat pumps. And I had a great question from a utility when I gave this training last week. Why didn't you just use the UES measure? Well, true. If these are measures that can use UES, go that route as our flow selection flow chart would indicate. But if for some reason, the windows don't quite meet a UES measure, but you can still quantify savings using custom project, then go that route if you so desire. This campus building here didn't have a meter on it. It was kind of one of those buildings on campus, and the meter was way back, captured data for many buildings. And even if it did have a dedicated meter, window upgrades and heat pump upgrades, savings level to the whole building consumption may be hard to quantify, or M&V using meter-based energy modeling. So, this approach just kind of walks you through the EC with V using some off-the-shelf standard software, eQuest. Tries to emphasize, the transparency of the inputs that go into this, because, eQuest, does your utility have some folks that use eQuest software? We don't want a bill either.
Yeah, I know Tom and Craig have used it a little bit.
Craig, yeah, we have Craig Bowles, who's our commercial engineer. And Tom Osborne. Yeah, our kind of eQuest pros have long retired, so there was a gap until Craig came around, perhaps Tom. But yeah, it gets expensive to hire a consultant to do this, so sometimes we may just rely on that consultant to bring us, as long as they follow this approach that clearly describes what inputs they've done, and we can kind of track code they're applying based on that baseline. Because I think another topic of discussion from this example is that the windows are there, that could be existing equipment eligible. If the heat pumps that are in place are operational and still can run for future years with proper maintenance, we could again use existing equipment. But I think kind of what I heard from some examples from Seattle City Light, maybe choosing a code baseline is the preferred approach here. That's what this example walks through. They had old windows, they had old heat pumps, but they're going to first look at, well, what would code minimum windows, what would code minimum heat pumps be, then taking that additional step to higher efficiency windows, higher efficiency heat pumps. So this walks through that example, and there's some values, U factors, and SEERs, and HSPF values provided here, and all of it inputs into the baseline model. And understanding operating schedules, all that factors in too. And typically when I see an eQuest summary sheet, that information is available, 1 or 2 page handout. But if it's some reason if it's not, we want to request that in some supplemental documentation. So This calculations happen to use weather data from the local, in this case, it's Salem, Oregon, TMY3 data. And you run this model using first the baseline equipment, and you step through the final higher efficiency data. That's kind of what this table is emphasizing here. You can see pretty low savings based on configuration of the building, occupancy, schedule, all that. We have on the far right breakdowns of a building equipment use on end use, space coolers, space heaters, down to lighting. And obviously the equipment that's not upgraded, that's not impacted by the Windows upgrades and the heat pump upgrades, should consume the same before and after. And we see that with miscellaneous equipment. Yes, printers, computers, etc., coffee makers. And bottom one being area lights, no impacts to that. But we do see savings from this analysis based on the cooler, heaters, of course the heat pumps themselves, ventilation fans, and a very minuscule but apparently calculatable pumps, savings of 40 kilowatt hours. And all provided here is a kilowatt hours per year as well as a percent savings. And again, if this methodology was used using simulation software, kind of what follows, I mean, that savings result would be desirable, but also this narrative description, kind of listing all the input assumptions, schedules, operations, showing them side by side. If electronic copies of the input and output files be desirable, I'm sure we always follow through on that, but it is followed through on with some of the energy modeling of other sectors. But yeah, listing what version of software is used and just kind of stepping through the rest of these, making sure that the appropriate code valid, compliant code minimum values were used, referencing what code was relevant at that date of the custom project proposal. Because as we know, codes get updated, and just because a completion report may not happen until say 2025, the impact of the current code at the date of the proposal is relevant and applicable. That's kind of the summary there, and I hope you want to revisit that. Third example is kind of around vendor software, might be proprietary used, and it's around fast acting doors. Could be, you can think of various other vendor supplied software tools, but we've seen in commercial and industrial a number of fast acting door projects replace kind of manual doors that tend to stay open longer than they should, all that cool air out into the environment, or make the refrigeration systems work harder than they do with a high-speed acting door. So I just highlight, this says it's in Salem, Oregon. I need to change that too, because the analysis is more in Puget Sound area. So just being totally transparent here. But yeah, there's these types of EC with V, clearly stating what the the temperature maintained in the refrigerated space, what the temperature is in maybe non-refrigerated space, what the measure's doing to save energy, how is the practice of existing baseline conditions, very slow use of doors, maybe there's cracks in the doors and the infiltration, all these things are documented in the operating hours, clearly 18 hours a day, 6 days a week. Yeah. EC with V, again, And we may take some measurements at the building of, once this door is installed, how fast does it open and close and how many times a day. That's data collection that's useful using a tool like this. We're not going back and putting meters on the refrigeration equipment before and after. Savings aren't high enough to justify that. Basically, the engineering behind this measure seems reasonable enough to use an EC with the approach. And so again, documenting what the baseline conditions are that will likely continue into the post period, but refrigeration, warehouse temperature, relative humidity setting. These are things we might be able to read off of a facility system or maybe just document talking to a plant staff member. Dimensions of the door, important to input into this tool. So those are data written in and plugged into the tool. We, sometimes these proprietary tools, can't have a working, maybe you're fortunate enough to get some working knowledge. Sometimes we're just left with a PDF printout. We need enough information to go on to at least do our own calculations or comparisons to some other similar projects we've measured, verified in the past, see if savings seem reasonable.
Question on that. So on a tool, maybe Cascades refrigeration tool, maybe. Have you guys done your own verifications on those? Or?
Yeah, we have measured, verified years back. Felt comfortable with the tool as it goes forward, but they've also been evaluated. Right. So gone through an impact evaluation. Passed the muster in that approach too. So
we've seen one or two of this come through. It's been like, it's Cascades tool, BPA must be good with that. So
yeah, as long as they're following these, transparent assumptions and such. Yeah,
we verify with the door time.
Yeah,
I have my own model that I use also.
thought so.
And it's based on conduction and convective losses. But I always, talk to other Todd and, you guys, I think your model works better than mine if you have strip curtains. If the facility has strip curtains.
Yeah, that is another mention in here. It does have manual acting door plus strip curtains. So yeah, that is noted as well. So, but no, we welcome other tools to compare with, rely on engineering fundamentals and thermodynamics, such. So heat transfer. But I think, kind of just documenting what the dimensions are, what the conditions of the interior cold space, and just the key inputs. What type of refrigeration system is it? Ammonia system, and understanding. Again, we're not going to pre and post meter these based on the standard efficiency. That's packaged condensing unit and the evaporator fans, those suction values listed there, will clearly be comfortable with the behind the scenes calculations over the years as we've used this proprietary tool over the years. And so once that new fast acting door, a beautiful door by the way, installed, its dimensions should be the same, but we would document that and rely on some post reporting period data collection. Could put an amp meter on the door to also quantify on off open closed operations, but there's also some on off data loggers available that you can do is just record 1, 0 over a period of time, 2 weeks in this case. So comparing that and using a stopwatch too, cycle time for each door. the on-off testing should give that data, but that stopwatch, good tactic to apply as well. And, invoices, part of a completion report package, further confirms what was installed.
Yeah, I don't know if your model uses it, but on the one I have, the baseline, the width of cracks on the periphery really makes a big difference. So I don't know, but I mean, some of these old doors are so, could be a half-inch gap, just always there.
Like it takes infiltration into consideration with those gaps. Yeah. Yeah, it shouldn't be ignored.
Quick question. So
Yeah.
what's the purpose of using the stopwatch to collect the cycles? Because you should be cycling the same before and after.
Yeah, that cycling up the door should be captured with that on-off post meter. Well, actually, it's a capture, but there is an input. It is automated, but just seeing, as the door opens and closes, just how long that time is, the reporting period.
It's
Is-
different. I always do a cycle time with the video.
Oh.
Yeah, it's always different.
Is it the video short term?
Well, I usually use a stopwatch and I do it 4 or 5 times to take an average.
It's good practice.
But a lot of times, for I don't know the reasons, but closing time will be slightly longer than open
Or seat it properly.
time. Another thing about it, and Todd has been doing this, is to tell them to cut their hold time down. That's a lot of times it's way too long.
Todd, by the way, is Todd DeBeer, and he sit for Seattle City Life and also some utilities up here. But yeah, he's very experienced in refrigeration systems.
Well, the door goes up and then it, so that it doesn't crush the forklift driver, it stays up for a while.
Yeah, safety considerations in this automation part, and you gotta give it time. And I think there's some safety built into that if somebody just stops right there, it's not gonna come down and crush them, but just to avoid that close call. So based on the data logging, it was, there was a wide range per day between 68 and 102. And so an average 78. And the occupancy schedule shown here, we're using 18 hours a day of business during 7 days a week. And the door cycles, being slightly conservative, have chosen to be 70 for each day, each month of the year. But this output, again, should be clearly part of the package, and savings may be done in that, but could be simultaneously done in an Excel side, do some comparable work to this proprietary software. But again, averaging typical weather data, because that driver is outdoor air temperature to the indoor refrigerated conditioned space, and the number of door openings and closings throughout the year. Savings using this tool end up being 165,115 kilowatt hours per year. So again, well within the EC with heat threshold, and all of the steps we described along the way seem acceptable for a EC with the, again, we just threw that savings number out there, but there should be also a quantification of what baseline was, energy annual consumption, what the post annual consumption to arrive at those savings. And I will send these for uploading your access once we're done here today. The last one is it's kind of that custom case. We see a lot of fast acting doors, we see a lot of air compressor projects. So tools are developed that can be replicable different times using EC with V. Sometimes we get these projects that are very, very site specific. We have to engineer kind of a customized spreadsheet analysis. And this is one example of that. There's others I'm sure you might think of, but the sawmill, has a lot of waste for making lumber, and that waste is used to fuel a hog boiler that relies on chips. And so this boiler operates year-round, and the sawmill itself doesn't operate 24/7. It does if production's good, demand for lumber's big, but there's generally still shutdown days, and some of those for maintenance reasons, some of those market-driven. Just not making lumber but that boiler needs to continue running. Maybe it's not spoken of, but maybe it's creating power that's being shipped off the grid. But so it needs to run. But what was identified in this project was a very inefficient chip delivery to that boiler when the mill wasn't operating. One of the graphics here down will show that. So it's creative engineering, found ways to make a new conveyor system, used a lot less energy than the whole system needed when the sawmill was running. But initially, still estimated energy savings was done, and it's like, well, it's not going to be over 400,000. EC with V, using spreadsheet calculations with some data collection, will be acceptable. So that kind of system boundary will be around this whole transportation process. We'll show it below to you, and we'll do a summary of all these electric motors that are needed to convey this hog fuel around. There's some bigger horsepower, like a 300 horsepower wood hog or a hogger, chips up some of those larger chunks into chips for feeding the boiler. And some of these others, these conveyor motors are pretty small, a couple horsepower here and there. But regardless, this process shown below, the old hog fuel stockpile feeds up some front loaders and conveys down the line finally to the boiler on the far right. Sometimes when the plant wasn't operating, the sawmill wasn't, that stack conveyor would just keep on doing this endless loop, which was some inefficiencies identified there. So a graphic, just a simple schematic, is a good deliverable, go along with any custom project for that matter, but the CC with V, that isn't exactly the one that came with might have been a picture of some hand sketch on a whiteboard. It was part of that, but we prettied it up here for this example. But the baseline summary of all these dumps and conveyors are listed here, and the calculated power would be provided ideally in an Excel file, that instead of just listing 1.9 through 3.4 kW, you either have a very clear calculation, 5 horsepower times conversion 0.746 kW per horsepower times an assumed load factor, all that. And some of that is kind of listed here on the far right, assuming power factor of 0.5. These are pretty low loaded motors. And the one that was measured, that hogger, 300 horsepower, even though this is EC with V, one could have used calculations, but that was decided to put a data logger on it just because it was large enough. But one could do EC with V with a calculation cage up for that auger too. So again, all those questions.
Why is that power factor so low?
I guess it's pretty unloaded much of the time. This, I've seen some pretty poor power factors on lightly loaded motors, sometimes 0.3. So,
Wow.
yeah, probably a good reference table to, or some engineering experience on, a sawmill equipment would be needed to justify that. But yeah, I've seen some pretty poor.
Aaron suggests large motors moving slowly.
Large motors moving slowly.
The power factor.
Thank you, Eric. These did require spot measured amps. So yeah, one would question if they were spot measured during fully loaded or spot loaded during lightly loaded conditions. There's some narrative thinking this EC with V kind of clearly describe that. But regardless, low power factor is conservative. I mean, for estimating baseline energy consumption, sadly, I've seen some cases where a consultant will claim a 0.9 power factor on the lightly loaded equipment. That does boost your baseline consumption, which does trickle down to more savings potential. So conservative approach here would be that, but maybe some further narrative in here to better describe to future reviewers, in-house utility staff, or BPA, or a future evaluator. Shows that.
I've never been to one of these places. Would they normally have some kind of torque metering on there that they would follow? Because I would think you would have really high torque and that it would vary a lot.
Would vary into a few sawmills that don't recall torque meter the equipment. No, I've seen it somewhere though. But where? Think about that. So calculated power though, that whole system that we saw the schematic of earlier is 182.8 kilowatt. And apparently that is that 24/7. So, again, EC with V may not have captured full when the plant's shut down, when the plant's in operation. So we kind of want to revisit that too. But once this new conveyor was installed to be able to bypass all that, majority of that equipment, it just was able to only run when the sawmill was down. Again, that's another question. We give these projects 10, 15-year measure life, and we're measuring for this first year savings. So we don't know if a sawmill is going to shut down in a couple of years. We've seen many sawmill shutdowns, but we don't imagine those. We do our best first year analysis of savings and M&V that, or use EC with V for that. But that's just kind of a little background. This new system in green, showing that new conveyor, that's the only thing that conveyor that needs to run. Plus when the sawmill is down, was measured in amperage. What was really the key driver here is the how many hours will that operate, and the they use a data log for 4 weeks. felt that was typical operating conditions enough to be able to extrapolate out to a full year. And that low horsepower motor was calculated. We would want to see that calculation. Motor nameplate times conversion times assumed load factor and all that. It's pretty minuscule average for kilowatt hours per year used. And again, all this be transparent and available to review in an Excel spreadsheet. And that just kind of these screen showings. Final one is, well, what was the baseline power? And again, it's going to operate when the sawmill's operating, and this new conveyor won't be operating. So we're really only looking at that 1,454 hours annually when the sawmill isn't running. So all these multiplied by those hours to get to kilowatt hours. Savings are right in that EC with V ballpark, less than 100,000 in this case.
The energy savings on that last line off.
There is some rounding error there, I see. And that is the fun thing about rounding. It's a whole topic in itself. I went through this. I pretty should have highlighted that, but the new system power should be like 0.66. It's rounded.
Well, I mean, the correct figure, I think, is directly above here for the energy savings. If you scroll up a little bit, it's got 93,858 there, just a little above that, right there. That's-
Oh.
Yeah.
Thank you. I'm gonna highlight there too for keen eyes. Thank you.
It's incredibly insignificant.
Well, that's another, I don't know, whatever you incentivize, 25 cents.
Yeah, right.
Anyway, the last one here, which I'll just kind of keep on this preview, just for kind of fun to explore, is the whole building of using an ECAM tool. And this is a DDC upgrade. And these are just screenshots of ECAM themselves that we have baseline data preceding the installation of the controls, and we have post data after. And we're going to look at this normalized energy savings, kind of apples to apples, those two models using TMY3 data. So it's an eyesore, I know, or you really got to squint, but with 12 months of data collected during this baseline, we have temperature in the x-axis, and we have energy consumption for the y-axis. And we have points shown in red for the actual monthly consumption, and a trend line kind of showing a 4-point model. I believe that's right. Right, we've got intercept, we've got slope, we've got change point there at around 59 some degrees, and we also have another slope for the cooling load. So it's nice, just kind of summarizing an ECAM transparently, showing the model statistics of it. There's an R squared, there's this coefficient of variation, and some fractional savings uncertainty, which, up front, we don't really know maybe what the energy savings are. We baseline model this, but if we say this control project will save 5%, we think, ballpark, then you can plug that in and see how that savings relates to the uncertainty of your energy model. So that's shown here. And again, the next step would be to kind of normalize that. If we are going to do a project, we can use avoided energy consumption. We've seen that formula many times today, but commonly HVAC control type projects driven by temperature tend to go with the normalized savings for long term. But we like to compare. Sometimes it's interesting. You have the time. So, what we had with that model based on the actual energy usage, temperature, that consumption month by month, January through December is normalized in this table far below, and some other information is provided by ECAM. And this project, which apparently didn't have a lot of cooling load, or it really changed the slope. What we find sometimes in the reporting period, you can't expect the same 4-point model to apply. So collecting the 12 months of reporting period data, all we have is a simple 2-point model as an intercept and a slope downward as the temperature increases. So this control worked wonders on the cooling load required during summer months, which is typically the hottest time of year. Or maybe there's something else to investigate. But regardless, a model was developed using 12 months of reporting period monthly data. And then we've also taken that and normalized it below, like we did baseline data using TMY3 data. And we then can look at this last graphic. When are the savings being achieved for this project? We have 12 months pre and post data. We have some different curves shown here. We have the baseline consumption, which is the gray. We have the reporting period consumption normalized, shown in, say, copper orange. Then we have temperature yearly through that. And then the bottom portion of this shows how the savings are achieved month by month. And we do see savings during the colder January, December, and February, November, and other months too. Yeah, we see a good amount of savings during those warmer summer months based on that. And we don't require reporting savings uncertainty. I think it's a useful tool for M&V practitioners to check, but it's not written in our beach reporting or any custom project. But I think it's important for your own QC purposes to compare. The measured and verified savings here are in the 124,000 range, normalized, and that's 11% baseline consumption, and the savings uncertainty is a little under 5%. So that's a good place to be for a project. But understanding how these EDC controls are really impacting the measures. I don't like to think just the black box, before and after, and here's the savings. But yeah, how did those controls impact the chiller on site operating in the summer? How did it control the heating equipment, air handler units? All that's information that should accompany this completion report, not just whole building M&V and leave what happened the mystery inside. I think that's takes us to noon. Where did the time go?
Yeah, are you done with this
I
content?
think I am. I do have a quiz. So, Elliot, there's your link to the M&V protocols document library where you can find this. So that question 1 was answered for you.
Yeah, I guess I just moved it so long, right? So
Like, what's that?
Trying to figure out how to talk to the people
Oh.
online.
Hello, people online. You're looking at the classroom.
There you go.
Oh, this is the first time we've used this classroom. Thank you. It's noon. I'm going to shut the webinar off.
Yeah.
Okay. And just a reminder, this will be available on our website. Give me about a week, please. Along with the materials that Todd presented. Thank you again.
Pleasure.
All
Thank
right.
you, Kate. Thank
Thanks,
you, everyone.
Todd,
Thank you.
we would definitely want to take you up on that meter-based training when you guys